Our last unit is about the sequence and series, and then my favorite part of the course, which so never enough time to do properly, but we'll do the best we can on finance. So a series, right, is simply a pattern, and so a sequence is a discrete function with a set of numbers arranged in an order, like 2, 5, 8, 11. You can see to get to the next term, you just keep adding 3. So each element of the sequence is called a term. So this is term 1, term 2, term 3, term 4. So that's what this says. You can also hypothesize an nth term called the general term, which would just be, term n, whatever n is, right? 12, 100, 1,000, whatever. Some sequences go on forever, or some stop, right? Depends if they end with this ... or not. Usually a term is identified by its position in the list. So the domain of these functions is natural numbers. They start at 1 and they count up by 1. So there's a first term, there's a second term, there's a third term, but there would not be a 2.7th term, and there would not be a 0th term, and there would not be a -2 term or anything like that. So the domain is the natural numbers, 1, 2, 3, 4, 5, and so on. The range is whatever's in the sequence. So, you just write the sequence, basically, is the range. There's not much you can do with that. There are two types of sequences we're going to study today. One is called arithmetic sequences, where you get the next term by adding something, or, a positive or negative number. Notice if you were to take the second term and subtract the first, 6 take away 2 gives you 4, 10 take away 6 gives you 4, 14 take away 10 gives you 4. So you could always subtract one term from the next and get d. Now, what this means, right? D is equal to t n plus 1 minus t n. Right? So Tn plus 1, by the way, this is like, again, mathematics speak. Tn plus 1 means the next term, and Tn is the current term. Right? So all I'm saying here is, if you take the next term and subtract the current term, you're going to get d, which is what we call the common difference. So what we do here is we say term 1, we call it a. Then we say term 2 would be a plus 1d. Term 3 would be a plus 2d's. Term 4 would be a plus 3d's, and so on. So we come up with the formula for an arithmetic sequence. Whatever the first term is, plus however many terms you've counted, minus 1, because you don't want to count the first term again, times the common difference. Okay? Really important formula. Tn equals a plus bracket n minus 1d. Now, a geometric sequence is a sequence where you don't have a common difference, you have a common ratio. So like you can see 1, 3, 9, 27, every time it's multiplying by 3. Instead of calling this a common difference, we call it a common ratio, and we call it r because it's a ratio, whereas d was a difference. Okay, the common ratio has a formula. It's this. Again, let's just unpack the mathematics speak. Tn is the current term, and Tn minus 1 is the previous term. So if n is 7, then you're looking at term 7 divided by term 6, right? So current term is Tn, previous term is Tn minus 1. Notice if the common ratio is negative, it can cause the sequence, it must cause the sequence to alternate positive to negative. Because if you take 5 and multiply by -4, you get -20. If you multiply by -4 again, you get positive 80, and then -320, and so on. Right? So if you write out a geometric sequence, again, it starts with the value a. Term 2 would be a times r. Term 3 would be a times r times r. Term 4 would be a times r times r times r, right? You're just adding another r every time. And so the general term is right here, a times r to the power of n minus 1. So let's use those pieces of knowledge now to work out a couple of things about the questions that we are being asked. So the first one says, state whether or not it's arithmetic or geometric, then state the common difference. Okay, so for this first one, you can see that a is equal to 36, t2 minus t1 is equal to 7, and therefore tn is equal to 36 plus n minus 1 times 7. Right? So for example, let's see if we can use our formula to get the 1, 2, 3, 4, 5th term. So what would be term 5? Would be 36 plus 5 minus 1 times 7. Sorry, it shouldn't be plus, I apologize. T2 minus T1 is negative 7. Sorry. Let's put a negative 7 there. And then whatever here, we can just move that 7 to be in front instead of behind. So we get term 5 is equal to 36, take away 28, term 5 is equal to 8. And you can see that it is, right? Term 5 is 8. This is an arithmetic sequence. Every term is the previous term, take away 7. So that's all we need to know. So you say, we could just move this up a tad. Is there any way to... just quickly get a little more room here. Negative 7. Okay, so the common difference is negative 7. So every time you every time you move, you get negative 7 as your okay, you get negative 7 as your common difference. Now this one, it goes negative a half, then positive half, then 3 halves, then 7 halves. This one is arithmetic. The common difference is positive 1. Negative a half is negative 0.5, positive 0.5, 1.5, 2.5, 3.5. Every time I'm just going up by 1. This one, this is a geometric sequence, and the common ratio is negative 4. Start with negative 3, okay, then go negative 3 times negative 4, and you get 12, which is the next term. Then you do 12 times negative 4, and you get negative 48, which is the next term, and so on. So every time you're just multiplying by negative 4. Here, this is also geometric, and the geometric sequence common ratio is 1 over 5, right? Because you have 5,000, then you have 5,000 times 1 over 5, which is 1,000, then you have 1,000 times 1 over 5, which is 200, and you get all the rest of them, then the 40, and then the 8, and so on. Okay, so the common ratio is 1 over 5. For each of the following sequences, state the general term. Okay, so the general term, to do the general term, what do we need to know? We need to know A, which is the first term, which in our case here is 15. We need to know D, which is 8. You can see that each one counts up by 8, because this is the common difference of this arithmetic sequence. Okay, so the general term is always the same. It's A plus n minus 1d. Therefore, the general term for this sequence is 15 plus n minus 1 times, sorry, what is the common difference? Was 8, right? Yeah, 8. Okay, so 15 plus n minus 1 times 8. And that would tell you any term you want to know. You want to find the 100th term, or the 50th term, or the 20th term, or whatever you want. To replace n with 20, and that's it. You get your answer. Okay, this one. Again, A is equal to 3. R is the common ratio, but it doesn't actually look like this is a common ratio, because to get from 3 to negative 1, you'd have to multiply by negative 1/3. But then negative 1 times negative 1/3 is equal to 1/3, not 5. So therefore, it's not geometric. Okay, this is arithmetic again, and D is equal to negative 4. I'm counting down by 4 every time. So the general term is simply a plus n minus 1 times negative 4. Again, you can clean this up if you like. Tn is equal to 3 minus 4 n minus 1. Something like that would be fine. You can also expand it into the bracket if you want. It doesn't make a difference. Okay, this next one. This one is geometric because I can see to get from 1 to 7 is multiplied by 7. To get from 7 to 49 multiplies by 7 again. So a is 1, r is 7, and the general term is simply 1 times 7 to the power of n minus 1. Okay, and again, you can just clean that up because you don't really need the 1, and you would get that. So that would be the general term for that one. Okay, this one, to get from 2 to negative 6, I need to multiply by negative 3. So 2 times negative 3 is negative 6. 6 times negative 3, negative 6 times negative 3 is 18. And 18 times negative 3 is negative 54, and so on. So this tells us that r is equal to negative 3, a is 2, because that's the first term of the sequence. Therefore, the general term Tn is simply equal to 2, and then put a bracket, r, so remember it's a bracket r to the power of n minus 1, like that. So we'll just write Tn is equal to 2 times 3 to the power of n minus 1. Negative, no, you got to be a bit careful here. The negative 3 to the n minus 1. Now remember, we didn't used to allow negatives to be the base of exponents, but remember here that the domain is only natural numbers, positive integers, and you can evaluate this to a positive integer, so it's not going to be undefined like it was in the other unit. Okay, find the 42nd term of the arithmetic sequence. Okay, so let's start with a is 5.5, d is 2.5, right? Because you have to add 2.5 every time to go up to the next section. Therefore, Tn is equal to 5.5 plus n minus 1 times 2.5. Again, we could just sort of expand this a little bit. 5.5 plus 2.5n minus 2.5, so we can just sort of get rid of the bracket there, and we get 2.5n plus 3, and that is that's the general term. So then, if I want to know term 42, all I'm going to do is 2.5 times 42 plus 3, and I get term 42 is equal to 108, I believe. Yeah. Okay. Find the 14th term of this geometric sequence. Okay, a is negative 10, r is negative 1/2, right? Again, how am I getting that? Negative 10 times negative 1/2 equals 5. 5 times negative 1/2 equals negative 5 over 2. Negative 5 over 2 times negative 1/2 is equal to positive 5 over 4, and so on. So every time I'm multiplying by the same thing, which is negative 1/2. So the general term here would be negative 10 times negative 1/2 to the power of n minus 1. Okay, so like that. And what I want to know is the 14th term, right, which would be negative 10 times negative 1/2 to the power of 13, which would be 10 over 2 to the power of 13. I don't know, 2 to the 13, what is that? 8,192. So that would be the answer. Okay, now again, we could just do this the other way. We could go negative 10 times negative 0.5 to the power of 13. Get more decimal places. And then we go 10 over 8,192 should be the same number. Okay, so that's that. Or something like that. It is also fine. You can leave it as a decimal unless it says. Okay. for the arithmetic sequence 18, -2, 14, 30, ... 126, how many terms are there? Okay, so first of all, the first term is a. The common difference is positive 16, because in order to get to each term, I need to add 16 to get to the next term, right? So the general term would be -18 plus n minus 1 times 16. Now this time I don't know n, but I do know that Tn is equal to 126. That's the final term of the sequence. So I'm going to set 126 equal to -18 plus n minus 1 times 16. So we'll bring the 18 over to our side. We get 144 equals n minus 1 times 16. 144 over 16 equals n minus 1. 144 over 16 is 9. So n is 10, so it would be the 10th term of the sequence. Let's just check my math on that. So -18 plus 9 times 16 gives me 126. Yeah, so I'm good. Okay, so since n equals 10 and T10 126, there are 10 terms in the sequence. Okay. Okay, same question, but this time a geometric sequence. So A is -4,374. What is R? I'm not really sure how to find R here. So R has to be equal to 1458 over -4374, and that has to be the same as -486 over 1458. So both of those things have to be the same, right? In order for this to be true. So let's test them. What's 1458 divided by 4374? So 1458 divided by 4374, and it gives me, again, you write fraction text f. The fraction is 1 over 3. Okay, equals 1/3, and it's negative because 1's negative and 1's not. The other one, right, 486 divided by 1458, and again, it's negative. Should put a negative here too. If you reduce this, we're expecting to also get 1/3. So again, let's just write it quickly. So 486, 1458, and it's the same thing, right? It's 1/3. So we get R equals -1/3. Okay, so the final term of the sequence is -2/3. Okay, so T, oh my. Okay, so so we know that Tn is equal to A, R, let's put R in brackets so we're not confused. Okay, that's the general term. Let's fill in what we know. Tn is equal, well, Tn, we know what Tn is -2/3 is equal to -4374 times -1/3 to the power of n minus 1. Okay, so that's what we know. So the first thing I'm going to do is I'm going to divide 4374 over to the other side. So the other side is already negative, so this is just going to make it positive. So I have 2 over 4374 times 3. Because it goes in the denominator, right? It would equal -1/3 n minus 1. Okay, so let's figure out what this is. So 2 divided by 4374 times 3. So let's just do 4374 times 3. 13122. Okay, I can reduce that fraction on the other side if I divide it by 2. So h divided by 2, I get 6561. So sorry, 1 over 6561 is equal to -1/3 to the power of n minus 1. Now, at this point, we need to use our knowledge of the same base in order to get these to be the same. So what we're going to do is we're going to go 6, 5, 6, 1 must be a power of 3, right? So let's start with 3, and then times 3, and then that number times 3, that number times 3, times 3, times 3, and then we get the number there, 6, 5, 6, 1. So it's 3 to the power of 2, 3, 4, 5, 6, 7, 8. So it's 3 to the power of 8. So what we've just found is that we can write the thing on the left as 1/3 to the power of 8 equals negative 1/3 to the power of n minus 1. Now, remember, since 8 is an even number, negative 1/3 to the 8 equals 1/3 to the 8, right? So they're because it's an even number, the even number of negatives would cancel. So what we can say here is n minus 1 is equal to 8, and so n is equal to 9. So it's the 9th term of the sequence. It might be easier in a question like this to use your calculator and type, so calculator, start with negative 4374 and multiply by negative 1/3. Then hit ANDS, the answer button on your calculator, times negative 1/3, and count how many times you have to hit equals before you get negative 2/3. You can also do it that way. You don't have to do it the algebraic way. It is a bit tricky when you get to this step. This step only works because it's an even number. If it had been an odd number, right? So let me see if I can explain this a bit better. So imagine I took the negative 1 out and raised it to the power of 8. Right? So if I take the negative out of the bracket and raise it to the power of 8, and then leave whatever's left in the bracket raised to the power of 8, right? And what you see when you do that is that negative 1 to the power of 8 is just 1, and therefore can be dropped. Right? So the negative can be dropped here because, or it can be moved outside, I guess you could say, so that this works. If you're not convinced, use your calculator, right? Just hit equals over and over until you get to the answer. Okay, the 19th term of an arithmetic sequence is 51. So term 19, I guess I can move this up now. Okay, the 19th term is 51. The 28th term is 96. What is the 35th term? So how do we do this? We know that term 19 is equal to a plus n minus 1 times 18. Excuse me. Sorry. Okay, we know that. A plus n minus 1d. We also know that term 28 is a plus 28 minus 1d. Now what I'm going to do here is I'm going to subtract these two equations. If you subtract these two equations, right? So let's just replace, sorry, let me just write it one more time. So term 19 is 51 equals a plus 18d, and the other one, 96, equals a plus 27d, right? If I subtract these two equations, what happens? 51 minus 96 is negative 45. And then I go 18 minus 27 is negative 9d. And therefore d equals 5. Right? So you see, if you subtract the two of them, you cancel out the a. And then all you're left with is this number, and you can figure out d. Now if d is 5, okay, let's go back to what we know about term 19. 51 equals a plus 18d. 51 equals a plus 18 times 5. 51 equals a plus 90. So negative 49 equals A. 39. Right? Negative 39, I think. Let's test it with my other equation. So 27 times 5 plus negative 39 should give me 96. 27 times 5 plus negative 39 gives me 96, right? So okay, so this is good. So we were just able to reason out that the first term of the sequence must have been 39, and the common difference is 5. So when I want to get term 35, right, it's negative 39 plus 35 minus 1 times 5. So negative 39 plus 34 times 5. 34 times 5 is 170. So term 35 would be 131. Okay, and that would be your answer for that one. So if that's a really good question. I think that's a good one to give it a try. Go over it again and see if you can do it. Okay, same thing for a geometric sequence. Now this can be a bit harder, but let's see if we can do it. So term 5 is equal to 1875. Term 7 is equal to 46,875. So what do we know about this? 1875 is equal to A times R to the power of 5 minus 1, or 4. And 46,875 is A times R to the power of 7 minus 1. Okay, so again, let's just write it a bit cleaner. 1875 is AR to the 4. 46,875 is AR to the 6. Now, you can't subtract these two equations. So what I suggest we do is let's divide. So what I'm going to suggest we do is let's take term 7 divided by term 5. Sorry, term 5. Okay, term 7 divided by term 5. So 46,875 divided by 1875. What does that tell us? So let's start a new one. 46,875, 1875. And then we have A divided by B. And the answer is 25. Okay, now I'm also going to do the formulas. T7 divided by T5 in formula form. AR to the 6 divided by AR to the 4 is equal to, what would happen there when you divide? A divided by A cancels. R6 divided by R to the 4 is R squared. So we come up with the conclusion that R squared is 25. Now, the tricky part about this is that R could be equal to plus or minus 5. You don't know. Because the term in the middle, right? The term in the middle, it could be the term in the middle could be 9,375. So let's just do it like this. So, okay, it could be 1875, then negative 9375, then positive 46,875 again. Or all of them could be positive. Okay, there's no way to know based on what we have here. And then it says find the 10th term. So let's find, so again, case 1, I said R equals negative 5. Case 2, R equals 5. We don't know which one it is. But in either case, we need to find term 10. So term 10 would be A. I guess do we need to find A? Is there a way we could work around it? We can work around it for sure, but okay, term 10 is A times R to the 9, but we don't know A, right? So we should go back and work out A. So let's go back and use one of the terms we know. So we know that term 5 is 1875. let's go back up a bit. 1875. So term 5 is also equal to AR to the 4. 1875 equals A negative 5 to the 4. And 1875 over 5 to the 4 equals A. Okay, so 1875 divided by negative 5 to the 4 gives you 3. Okay, now I guess I can leave this as a negative. It doesn't matter because it's an even power, but let's just so we're not confusing, let's write it like that. Now again, the same thing would be true here. $1875 equals A times 5 to the 4. So 1875 over 5 to the 4 equals A, and A equals 3. So it would be the same whether the A doesn't change, right? Where the sequence starts doesn't change. Okay, so let's go back here. So term 10 would be 3 times R to the 9. Term 10 would be 3 times negative 5 to the 9. Term 10 could be oh boy. Oh, right, it's negative. Okay, so it could be negative. Is this right? This seems. Oh, I wrote the wrong thing. It's not negative 10. Okay, 585 9375. 585 9375, and it's negative. Now over here, of course, you would get the same thing, but it would be positive. So again, we don't actually know which one of these is right because based on what we know in the sequence, we're unable to determine if the R is a positive or a negative. So just be a little bit careful when you're doing geometric ones. If you get an even power and you take the square root, you got to remember that it could be positive or negative. If this was a cube root, the cube root can only be positive or negative, so you don't have this problem if you're working with a cube root. Okay, last question of the day. It says a large movie theater has 12 seats in the first row, 14 in the second row, 16 in the third row, and so on. How many seats would be in the 8th row? If the last row has 40 seats, how many are there in total? Okay, so let's start with A is 12 because that's the first row. The second row is 2 higher, so the common difference is 2. So the general term would be 12 plus n minus 1 times 2, and then it says how many would be in the 8th row. So what would be in row 8? It would be 12 plus 7 times 2, 12 plus 14, 26. So therefore there would be 26 seats in the 8th row. Okay, then it says the last row has 40 seats. How many rows are there in total? Okay, so T n equals 40. 40 equals 12 plus n minus 1 times 2. Let's bring the 12 over to the other side. 28 equals n minus 1 times 2. 14 equals n minus 1. And 15 equals n. Therefore, there are 15 rows in this theater. Okay, and each one is 2 higher than the last one. So that's it for today. Just a quick review of what an arithmetic and geometric sequence are, and then tomorrow we'll work on the series part.